All right. 6.1 is about an equation called Ohm's law. This is the equation that we talked about during the lab. V equals IR. In this lesson, however, I want to talk a little bit about what each of those things means. What's voltage, what's current, what's resistance. So we'll start with voltage. Voltage is the electric pressure in a circuit. So voltage is dependent upon how strong the battery is or how strong the power outlet is. In your home, the voltage of your power outlet is always 120 volts. I believe it's a little more complicated with your home power outlet because it uses something called alternating current, an invention by Nikola Tesla. But the basic physics we're doing in this class is that of more of what Thomas Edison used, direct current. So in this type of current, you have electrons that are being pushed directly through the circuit as opposed to alternating current where the electrons just go back and forward. It requires a lot less energy. Anyway, voltage, it's a concept called static. It's related to a concept called static electricity. There's a whole chapter on this that we could do, but being only 1 year, we can't really get through that. So we just kind of say that it's the electric pressure. This is an easy one to remember. The variable is capital V, and the unit is also capital V. Pretty easy to remember. Voltage is represented by a V, and it is measured in volts. Okay. Current is a little more complicated. Current is the amount of electrons that pass through a point per second. So if you picture a bunch of people walking through a hallway, the current of human beings is how many people pass through a doorway every second. So this is the rate at which charge flows in a circuit. The cool thing about current, I think, is that it's not always electrons. Sometimes it's charged particles, which we see in the human body. In the human body, you do have electric current going from nerve to nerve, but you also do have, like, for example, between those nerves, you just have charged particles moving. So current is relatable in biology as well. Rate at which charge flows in a circuit. I think that's about it. There is a special equation for current, and it is just a rate equation, meaning, well, we can kind of see what it's going to be. Speed is the amount of distance. The rate at which you cover distance. Current is the rate at which you cover that charge passes, so it's similar. Like speed is distance over time. Current is Q over T. I'm going to draw my Q. This looks like a 9. So I always go back like that. You can draw your Q however you want. You could do a capital Q, even though technically that is another concept called heat transfer. But we're not going to learn about that, at least in the near future, so you can leave it as capital Q if you prefer. So here's the equation for current. I equals Q over T. Current is the amount of charge passing a certain point in a given amount of time. So this is current. Pretty hard to remember that current is represented with an I, and the unit is amperes, amps. I always think CIA. Current is represented with an I, and it has the unit A, CIA. Q is charge, and here's where it gets tricky. The unit for charge is capital C. You'd expect that to be the variable for current, but not the case. Capital C stands for coulombs. Of course, time is measured with seconds. So that's how we measure current. Current is I, it has the unit of A. Charge is Q, it has the variable of C. Time is T, it has the unit of S. Fortunately, we don't really test on units this semester, this year. Being online, we have that weird software. And finally, we get to resistance. Now, resistance is not something that we deliberately introduce to a circuit. Like, why would you want, like, you're creating a voltage over here. Why would you want to slow down the current that you're producing? And that's not something that you do on purpose. It's just a byproduct of like whatever you're accomplishing. Let me write down the definition before I explain that a little further. So resistance, we're just going to say it's opposition to the flow of charge. So it's the opposite of voltage. Voltage is electric pressure. We're pushing forward some charges, and resistance is slowing those charges down. So we have this battle between resistance and voltage. You don't, like I said, you don't introduce resistance into the circuit on purpose. It's just a byproduct of the thing that you're using, like little headphones. Headphones, you don't want, like there's a current going through the speaker on the end here. You don't want the current to slow down like deliberately, but you do want to produce sound. So in the process of changing this electric energy into sound, you're going to slow down the electricity. So that's the case with any form of energy change. In a light bulb changes electric energy into light, and as a result, some resistance is produced. And so eventually, the battery runs out. So the more voltage there is, the more current there is. The more resistance there is, the less current there is. Those are kind of battling one another. Here's our Ohm's law. This is called Ohm's law. This is what the lesson is all about. V equals IR. And we'll break down those units once again. So, of course, V is voltage. And the unit is capital V. V stands for voltage, and it is measured in volts. I stands for current, and its unit is amps. R stands for resistance, and it has the coolest unit of them all, ohms. It's like a horseshoe shape. Or if you take the True Religion logo and you flip it upside down, you get the ohm, spelled O-H-M, Ohm's law. So the unit for resistance is ohms. It's a little horseshoe. Okay. I'm going to try to make up an example that utilizes both of these equations. We're going to calculate charge in a certain amount of time, and I'll give volts and resistance. Okay. So here will be our example. I think we'll be able to fit, yeah, we'll be able to fit this on a couple, maybe 4 lines. Okay. Here we go. A flashlight using a 9-volt battery. A flashlight using a 9-volt battery has an internal resistance of, we'll say, 8 ohms. A flashlight using a 9-volt battery has an internal resistance of 8 ohms. How much charge passes through the light in 1 minute? A flashlight using a 9-volt battery has an internal resistance of 8 ohms. How much charge passes through the light in 1 minute? So we'll break it down. Always start, I guess this is just my opinion, but I think you should always start with defining the problem. What are we trying to calculate? Obviously, they have it right here. How much charge? If we look back at our notes, we can figure out which of those things represents charge. It looks like there she blows. Q is charge. So we're trying to calculate Q. Let's write that down. Trying to calculate Q. In the equation, there was T and there was I. Fortunately, we have T right here. It'll be 60 seconds. But we do not have I. And that's where the other two come into play. Right here we have voltage. Here we have resistance. So we can use those two to find the voltage. Kind of up to you the way you want to do it. You can write down 9 equals I times 8 and then solve for I. Plug the number into the first equation. Or you can solve symbolically, which is what I'm going to do because it's wicked cool. So here's what we'll do. We're going to take the equation that's important to us. We're trying to calculate Q, so we'll start with this one. I equals Q over T. So if I solve for Q, I'd cross multiply. Yeah, I guess that's one way of putting it. Cross multiply. Q times 1 equals I times T. So here's what we have. Q equals IT. From there, we'll plug in something for I, and that'll be using this equation. If you visualize dividing both sides by R, or you can write it on paper, divide both sides by R, this R will cancel out and we'll have V over R on the left-hand side. So basically, that means I equals V over R, and I'll plug V over R into this equation. Long story short, here it is. V over RT. We'll put those two together. Q equals V over R times T. There's our equation. We can plug the numbers in to solve that. So Q equals 9 over 8 times 60. And I'm getting 67.5. So our answer, 67.5 coulombs. My advice for this chapter is make sure you have the units memorized. It's not familiar to us in the same way that mechanics is. Like most of us know that meters per second is velocity. Most of us knew that miles per hour was velocity before coming into this class. So that stuff is a little more familiar. However, very few of us will see volts, ohms, coulombs, amps. Very few of us will see that going into this. So my advice would be to make sure you have those memorized. One way to do it, let's see how much time we got here. We're good. One way to do it would be to make like a little chart and fill in the chart. If you can't fill in this chart, you can't pass the tests. So write this down if you wish. We would go with resistance, current, voltage, charge. I don't think we're missing anything else there. Then you would go variable and unit. If you can't fill in this chart, you'll have a lot of trouble solving problems. But if you were to fill it in 2 or 3 times, you'll have it aced. So by looking at this, you should know variable. Okay, if I'm looking at an equation, what's the letter that I use for resistance? It's R. If I'm looking at an equation, what's the letter I use for current? Capital I, as seen in V equals IR. What's the variable I use for voltage? It's V. What's the variable I use for charge? It's Q. And it's important not to mix up variables and units. The unit is the thing that you measure it with. So if you get a number at the end of it, the unit is what you write after the number. These are the letters that are in the equations. So the units, resistance, like I said, has that cool unit, ohms, 8 ohms, 10 ohms, 16 ohms, whatever. Current is measured in amps. This is the kind of like the amount of power, but we'll get more to power later. Voltage is also related to power. Cool thing about voltage is the unit and variable are the same, and the unit for charge is C. So make sure you can fill that in on your own. You could even try leaving this column blank and filling in one of these. So I guess you would call that the quantity column. The quantity, the variable, and the unit. Got to make sure you know those. So if you see something written in ohms, you should know that's resistance. Then you plug it in for R. If you see something written in amps, you know that's current, and you plug it in for I, and so on and so forth. So give that a shot. Leave that blank, fill that in. Leave that blank, fill that in. Leave that blank. Good practice if you think you'll have trouble mixing up the units and stuff. But I'll stop it there. Thanks for watching.